Hello and welcome to our first community call of December. Today we're going to give another update on the progress we're making on wasmCloud V2, specifically talking about how services work. We still are working fast and furiously on it, so there's a lot to be said there. And then I've got a couple changes I wanted to run by the community before I hit merge, just to make sure nobody is depending on those. So, Lucas, you want to get us started?
Sure thing. Let me see if I can steal the share. Yes, I can. Can see my screen okay there? Nice. Move this out of the way. All right, so we've talked a lot about components, how in wasmCloud V2 we can put many components on the same host under the same workload. And one of the things that we haven't talked much is services. And what is a service? When you submit a workload to wasmCloud V2, you add many components that will compose the with world. So you have one component taking care of your payment API, another one for blob store, another one for some for like doing login, and you add all these components together. And through the imports and exports, wasmCloud V2 knows how to connect them together, how to connect one export interface to an import interface. And as long as all interfaces are being fulfilled, the workload starts. We also have within the scope of the workload something called a service, which we have not talked too much because getting it to work is really hard, but also because we wanted to make sure that we were validating the possibility of doing that. And what is a service? A service is essentially the local host of your component. So it's an individual component, but it's configured inside its own section in the workload. So this what we're looking at here is the Protobuf definition for a workload, which is used by wasmCloud V2. All the components that compose the with world will go inside with world. But then we also have this other one on the side here, which is a service, and it's outside of the with world. However, this service can interact with the with world. What does this mean is this is essentially a WASI CLI run component, which can call any interface exported by the components that are part of this with world. What this means is that if you want to create the most basic cron implementation in wasmCloud V2, what you do is you add your components to the with world, and you add a service doing essentially while true, sleep, call the with interface from a component within your workload. And this shows that we can, from the service, call things inside the components in the with world. Now, how about the other way around? And can we call things inside a service from components in a with world? No, we cannot, because the key difference here is that components inside the with world are invocation based, and the service itself is a stateful thing. So at the moment that you schedule a workload, we start the service right there, and the service will be up and running as long as the workload is scheduled on the host or it crashes. The very interesting thing here about service is, in saying that it's the local host for your workload, is that services, they can open TCP sockets, and they can also open TCP sockets in the sense they can listen to TCP sockets. So where a component can connect out, it doesn't make much sense for a component that is stateless to open a TCP socket because, well, it doesn't have state. So what's happening here is The service is a way for us to open TCP sockets and have the components in your workload connect to that TCP socket. And by doing this, we have now a point that can hold persistent connections throughout the entire lifetime of the workload and provide connection pooling, provide proxying, or do any adaptation of protocols bridging the with world to the TCP world. So this pretty much to summarize components. Inside a workload, we have components and we have a service. The components are stateless, invocation-based. They can connect out to TCP, but they cannot open TCP ports. They cannot listen on TCP ports. The service is stateful. It's just like a binary, essentially like a old school binary. And it is automatically started and restarted when you schedule the workload on a given host. It can listen on TCP ports, and it can also connect to TCP outside of the cluster. And you can literally imagine that if you are in a component and you open a TCP connection to 127.0.0.1 or the name localhost, this is where you're going to land. So you're not landing on the Linux OS that is underneath. You're landing within your workload. This is the boundary. And doesn't matter the number of workloads that you have, this service here can listen on port 8080, and this service here can also listen on port 8080 because they are fully isolated from each other. And this is happening inside the same wasmCloud V2 host. How is this going to be useful? You can imagine that you want to connect to MySQL, and you really don't want to open a new TCP connection to MySQL every time an invocation comes in your component. So what you do is you run an aggregate, like a connection bouncer here on the service that will manage the persistent connections over to MySQL. And every time a component needs to communicate with MySQL, it can open a localhost connection to the service, which then proxies it out to MySQL. This way, all the connections on this side here can be persistent, and connections in here, they only live during the invocation of each component here. A bit of an advanced use case, but you can imagine that this is a good place to run things like a PG bouncer, any connection pooler, or if you want to expose something in TCP that components cannot do, it's a place that you can have state even. So let's say you have a very tiny HTTP server that needs to keep track of a hash table. You can run that as a service and have the components querying it all the time. And this is going to be really fast because this is essentially a pipe inside Runtime. So there's pretty much no real TCP IP sockets involved. It's all virtual from the standpoint of the OS. Now, how is this going to be used? Here I have a very tiny component. So this is a WASI CLI run component. And I'm creating a TCP listener here on port 7070. And for every single connection, we're going to accept the connection, and then we're just going to echo the bytes back. So essentially just doing an echo server in WebAssembly. And if we go here to wash, we can bring that up in wash dev. And notice that I'm running here like a development branch of wash dev because all these things are happening as we're speaking. I'm running cargo run on dev, and I'm going to remove this trace because we don't need that. And I'm passing exactly the example TCP service, which is this code here. We bring that up. So now the component is up, and we should be able to go to localhost 7777 here and interact with that. So anything that we write here, the component is echoing back to us. So TCP server in WebAssembly, pretty cool stuff. Now, notice that I'm connecting to it from my computer, and which is a bit different than what I just said, that localhost is isolated inside each workload. And I'm pretty much doing that here for simplicity of testing and showing. Uh, this is to say that this is why I'm doing this on a branch, because this is not the actual code that is gonna land. But you can see that this component is running, and really doesn't matter as many times as we connect to it, the state, the socket itself will be preserved. Is very similar if we were doing a really basic HTTP server in Rust, in Go, as a regular OS binary. And this allows us to do a lot of TCP conversion, TCP to WIT conversion, which is going to be important here as we advance from WASI P2 to WASI P3. The key thing is developing services with Wash is still something we're trying to figure out how that's going to look like. So in this local branch that I have in here, we have a special setting in your wash config JSON that says this component that I'm developing is a service. And this means that it will treat this component as a stateful component instead of a invocation-based component. And not exactly sure if this is going to be the configuration setting that we're going to keep, because there are a few other things we want to include here. For example, supporting multiple components to be developed at the same time. And that's gonna just a mini demo on how services can be used. So use cases involving TCP, use cases involving large amounts of memory, anything that needs to keep state across multiple invocations. This is gonna be the place to put that. Cool. Any questions?
Yeah, could you please go back to the service that you ran? So, okay, so this actually gets compiled to WASI P2.
Yes. So
Okay. I didn't
that's
even know
called
there was a W stood runtime spawn. I didn't even know that was a thing. Is that only in preview 3?
this
No,
is Visual 2.
Because I use what W stood all the time. I didn't know. So what is actually happening when you call? Sorry, I don't want to get too far afield. But what actually happening when you call W stood runtime spawn in P2?
I think that this is doing a Tokio runtime on a single CPU. But the thing is, WStud is encapsulating all of that for us, so we don't have to go like import Tokyo, import Hyper. So
But Tokyo
it's,
doesn't work in WASI P2. I don't.
it it work. We have also here the cron service, which is using Tokyo. So this would be how to get Tokyo.
Is this on the? But this is interesting. On the host side, you could use Tokyo. I know somebody like I accidentally added Tokyo, like forgot to added Tokyo to our thing. Yeah,
Yeah,
I know, Victor. I just know that Joel did a ton of work with Pete Mio and Tokyo, and that it was like all deferred to P3. Okay, thanks, Victor. You're very good at typing quickly. The so I'm just confused. Oh, interesting. So you are compile. You can have Tokyo, and you can just compile it. And Victor, could you just explain? Sorry, in words, if you don't mind. You don't have to. I don't want to put you on the spot. Like, but uh, how we can have Tokyo working without Joel's work? Because I know if I ever try to bring Tokyo into a Rust project and then compile to P2, it'll crash real fast. Okay. All right. Maybe Bailey. I'll
Yeah,
just read.
it's basically what Lucas said. Like it's just a single threaded executor. So
Okay.
like when you get inside that function, right? And like what wstood, I think the plan for wstood is to have it compile differently. And whether they'll have to or not, I guess depends on how fast P3 essentially as implemented in WASI libc makes it into the Rust toolchain. whether they'll have to sort of like make the spawn turn into like a wit bindgen spawn. So like right now, if you use wit bindgen, you have support for P3 async spawning tasks. That actually does P3 things. But yeah, basically on P2, if you want to have concurrency on a single thread, obviously you can use Tokio stuff there. And then eventually, like, so WSTD on P2 has to do that. WSTD on P3 has a choice, but obviously like they're going to want to use the actual P3 stuff. And then eventually, like once WSTD like just melts away, and then you just
use Tokio.
hit WASI P3, and then you get all that by default with regular.
So what's keeping us from doing requests then? If we have something like Tokio.
We have a fork of requests that does WASI P2.
Okay.
The challenge with a lot of these upstream libraries is that a lot of them don't want to maintain a not 1.0 release target. And so while we've contributed fixes back, the maintainers don't always merge it.
Okay.
So, yeah.
So then for mocks, could we do mock servers for tests and things like that with this?
Yes, with mocks, and the mocking here could be done in different ways as well. So
this would just WSTD have like a WSTD test. Wait, oh, it does because I use it, but I don't use it for mock HTTP servers though. That's interesting. Okay, well that's something to chew on.
Yeah, it's been a while. It's been a while since I had looked at WSTD, and I think this is looking really, really clean.
Yeah, that looks great.
It not having to do all that dance with
So if I had a service that had to call a particular API, the story before was to use a provider. So now the idea would to create a workload and have the workload manage the connections and like just talk TCP. And
correct.
okay, that'd be cool if it works all the time. I don't know. I mean, I'm sure it's even though it can do this cool thread spawn and I know it can do request like things in WSTD, and I do use it for that. But I don't know. I don't know. There's a lot of stuff that providers like native code can do that can get real tricky if you try to do it in WebAssembly. But yeah.
Yeah, our bet here is very much that cooperative threads is right around the corner. So in WASI P3, we already have implemented, and it's not actually WASI P3. Technically, it's at the component model layer inside the canonical ABI. There is basically like effectively a thread spawn call that you can make. And that is mapped and implemented actually inside WasmTime now, and also on the guest side in Wasm tools. And Sai, who's been working on this on behalf of Fastly, is now working inside WASI libc in those layers. And that's basically what a lot of different languages are going to ride along on and be able to compile to be able to take advantage of being able to produce a component that is able to do cooperative threads.
Yeah.
So having a service that can do this is going to be a key superpower with really great isolation. Scale way better than a provider. So there's definitely an alignment path, where we're like funneling closer, but maybe the lines haven't crossed yet. Is I guess where I would argue that right now.
Yeah, I can't wait. It'll be very nice. I mean, yeah, I don't know. Nothing you don't know, Bailey.
To note about so you mentioned wanting to do a request. The host does have WASI HTTP support built in, like a client support. So like if you're doing a regular like web request, you don't have to, build a service just to do that.
I think he's asking request with a W. I interpreted that as asking about the crate.
Yeah, the crate request. Okay. Yeah, sorry. That's the problem with all these things like JSON. It's like, you saying the name or you saying the project? That's why people pronounce it weirdly. But yeah, request. Okay. That looks cool. Somebody else have, do you have a question?
No, not really.
No questions. Okay, so we've got workloads, and workloads are going to especially kind of. I think, Victor, I think it was more about like maintaining like TCP connections and things like that, right? So like, especially for
Yeah.
databases, you don't want to be, like pulling up a new TCP connection every time you get a request. So that's the whole point of this workload, right? Is that it'll maintain those connections without the need for native code.
Yeah.
Okay.
Minor nit there is it's really the service that's inside a workload where it'll do this. So you could have a
Okay. The
workload
whole
that just
thing's a
has a
workload.
component in it.
I
Yeah, the
got you. The
whole
whole thing's a
box is,
workload.
yeah,
The
exactly.
service is the thing. I got it. All right. Yeah. Okay. Yeah. Okay. Um, so what is the deal? Are we still doing like, is there still gonna be like a SQL thing, or it's all gonna be at the TCP layer? It's all WASI TCP. So
I think the answer is it's going to depend on what your platform team wants to invest in and support. Um, I talked with Luke for 2 hours last night on this, and I very much made the case that folks right now that are end users really want their existing ORMs or existing libraries to just work TM, and there to be enough flexibility in the platform in this case being basically the WebAssembly runtime and host implementations that they can take most things and it just work. Then I think platform teams, and especially somebody like where Luke works, at Fastly or at Cloudflare, those types of folks who are providing services that other people are connecting to, I think very much they're going to abstract away the socket side of this world and be like, no, you talk my API to be able to talk to my service. And then they can make that extremely efficient. So
yeah, we lost you.
very, oh no, really? Me? Heck.
Yeah,
Am
it's
I
okay.
back?
I think I got it. I think I got
Okay.
it. It's good though.
All
I know
right.
though I'm not the only audience, I guess, but yeah.
Yeah. Well, I think I don't yield WASI SQL, not the query and exec where you just give it whatever and you can fall into the traps of not correctly doing your parameter initialization, that type of stuff. I don't think it'll be like that, but it will be much more like a direct API for everything you're doing there. So, anyways, I think the direction that wasmCloud is taking is definitely general purpose, ultimate flexibility, where people can dial that in as they need for their platform.
Yeah. No, that's great. It's good stuff. And then for Lucas, for the ports not conflicting, and that's because we're using the Kubernetes API server.
No, it's
Oh,
mainly because when the service requests a port to be open, it's doing that using the WASI APIs. So what we're doing is we're catching the call there, and we're telling the component, yep, we opened a socket. Here's a file handle, but that file handle is actually internal to the workload. So it's more like a Unix pipe than an
okay.
actual socket.
All right. Okay. So the Kubernetes API is just really around the DNS.
Correct.
Okay.
If you are in any other pod in the Kubernetes cluster and you try to see how many ports are open on the host, you're only gonna see the HTTP port open because all these other ports open by workloads, they are internal to the workloads. So that's the isolation boundary there.
Okay. I think I get it. I think it makes sense when we do these simple use cases and then I try to tackle a hard use case and then you're like, oh, but yeah, that sounds good. I like the direction. I think it's good.
Awesome. Yeah, it's kind of similar to running Docker with an HTTP server, and then you run Docker in privileged mode or passing your host network where
Mhm.
it's gonna lift everything to the host. So we're pretty much doing the first approach, which is everything is isolated inside the Docker instance itself. Just in our case, we needed a new name, so we called it workload.
Yeah, that's cool. Yeah, I hope it keeps going. I mean, I hope this works out exactly as you intended. Because yeah, that'd be great.
Thanks, Colin. Anybody else have questions? Okay. I have a couple other changes I wanted to call out. We have a release candidate from a couple weeks ago. We've obviously been staging a number of changes, including what Lucas is working on right now. That hasn't landed yet, and so we have an incoming release candidate, but I'm not planning on cutting one this week, unless somebody makes a call for it. I think we'll probably be talking more about that next week. I do have a couple changes that I wanted to make sure wouldn't impact anybody. The first one is this one. So essentially, and actually I've got extra background here, so I'll start with the background. We need to push our plugins that Watch depends on. And we kind of have a goofy way that blockage works where it determines where to grab these things. And so we can, on wasmCloud.dev, basically say, hey, go grab these interfaces from here on our GHCR. And so we had actually already set this up, but nothing was using it, as far as I'm aware. And I searched all around, and so I feel like I can make this change safely. Let me know if you are using it. I've kept this PR up for a little while because, again, it felt like a bigger change. The main reason why I need to change it from interfaces to components is that I'm obviously pushing up components here at plugins, not just pure interfaces. So I need this registry to actually be able to load normal types of components. I don't want you to think that it's an interface. It's not. And there's no easy way to like split the difference. As far as whackage registry is concerned, you could have a .wasm that has WIT definitions in it, like just a pure .wasm that is declarative about the interfaces a world could provide. And it can also have that type of declaration with the implementation of that world. So that's one call out. I have a bigger change. Hopefully it's chill. Obviously, we've been talking a lot about how wasmCloud V2 scheduling works, how workloads basically get scheduled. And we've introduced inside the wasmCloud Wash repository a runtime operator that Lucas created that manages all that and calls and handles our workload scheduling API for the V2 host. But we haven't closed the door on if somebody wanted to bring wadm forward in V2 and that be your basically scheduling mechanism. You could do that if you wanted. And so for that reason, I want us to rename this to wadm operator versus like doing like this is a V1 thing and this is a V2 thing. I'd like this to be its own thing. And it can be leveled up to whatever version it supports. I added signposts to say right now this is V1. And that way we can kind of decouple this type of operation from what we are running in V2 with Wash. And so anyways, I renamed the wasmCloud operator to the wadm operator. In theory, it should work.
And to kind of add a bit more context here, the challenge with this current incarnation of wasmCloud operator here is that it requires wadm to be there for all scheduling decisions, where in V2 there is no wadm. The scheduling decisions are performed inside the operator itself. So the first operator was essentially a reflector from wadm to the Kubernetes API. In V2, we actually have an operator that is doing work in the Kubernetes API.
Yeah, and I definitely wanted to free up and disambiguate the wasmCloud operator name and chart resource. Okay, any questions on that front? Alrighty. I just also wanted to, in our agenda, I had an item for just giving a general community update in the upstream WebAssembly side of the world. WASI P3 is progressing along. We had the design change for it's not a color, but kind of like a color for adding async to our functions. And that change has, for the most part, been implemented and rolled out inside wasmTools and wasmTime. Not yet on the Jaco side where Victor's working. Victor's landing is a major milestone. I don't know. Victor, you want to say more? I don't want to speak for you there. You have had a big unlock over the past week on async work. Do you want to share about that?
Yeah, I mean, there's not a ton to share just yet. There have been some small fixes that have gone in ahead of the sort of big PR that is being worked on, mostly because someone found like a little thing in like a basic like sort of example. Like for example, we don't generally recommend it, but if you directly like export an async function, for example, right? Like right now, the way it was returning your arguments, sorry, the way it was returning the result wasn't working properly. So I added a fix for that and pushed it out. So there's like a Jaco 1.15.4 or something like that is out now with that fix. But other than that, the async sort of work is ongoing. It's still experimental, but there are async components in there, and basically we're just growing the amount of async components that we know that we can support and making sure that the ones that we know about, like for example upstream, work. So that works still ongoing.
Cool. Yeah. So right now, I think we at one point had estimated end of this year for WASI P3 release, and now we're looking at Q1 for WASI P3 next year. Maybe January, maybe February. But it's progressing really well. Something else that I've got a update on is I might have spammed you, and maybe you want to know why. We moved WASI to a monorepo, and that really simplified being able to make monotonic updates like the one that Colin made. Colin, I don't know if you saw that I rolled out the WASI clocks wall clock to system clock change, and then now that is persisted in. Let me actually just bring it up.
Yeah,
so
I
you can
just
see it.
I just was going to ask you about this, so this is great.
That was
Just thinking
one of the big motivators for making this change. So like, if we look at here, now you can see that it's all aligned, and I also have automation that's very simple and straightforward to run. Unlike before when I had to do it across many different repos that had to be tied together, I can run a single publish, and it will publish each one of these and check that it got published and it works.
Are we going to keep tagging them with dates for the 0.3 stuff?
We'll keep doing release
Okay.
candidates until it's released.
Okay,
Basically, yeah.
great. Then I think I can move on to the time zone stuff for 0.3 now.
Yeah. So
After next week. Sorry, after all that stuff we're going to be doing next week. But yeah.
Yeah, I was about to say I think we're gonna have a pretty full docket next week, but yeah. So speaking of time zones, right now we have this gated as unstable, and we'd like it to not be unstable for 0.3, and that would be pretty cool. So that with the 3.0.
We just need
0.3.0 release. Yeah.
Yeah, we just need to get this stuff. Well, never mind. Sorry, I was taking a step back. We need to get the new stuff into wasmTime, and then get this into wasmTime for 0.3.
Right.
But yeah.
Yep.
All right.
So that's one thing. One other thing that Victor had asked me about earlier this week, and I realized I should probably just shout from the rooftops, which I think is pretty cool, is that wasi-otels moved to phase 1. So remember, phase 3 is like what we can guarantee stability and support for in both the WASI side of the world, the wasmTime side of the world, everybody's side of the world. It's not really even reached kind of like a state of stability or standardness until it has hit phase 3. But a phase 1 proposal does mean, hey, it's something that we're tracking and pushing forward in the W3C, and want collaboration and feedback so that we can move it forward and get it to a phase 3. And so that we've merged over. Right now, this WASI mono repo is a phase 3 only proposals, so you only see this tight set. So just like how it had previously worked for even a proposal like WASI HTTP, there's now a wasi-otel. And folks like Andrew and Caleb have made a call for more collaborators, more implementation so they can advance phase 2 and then later phase 3. Which is pretty cool.
Okay, so that's not part of the monorepo because it's only phase 2.
Phase 1, yes.
Phase 1.
Yeah. Phase 1, we don't have to go too far into the standards, but a phase 1 basically means I have an idea. The fact that they have a WIT definition and a spec is like cool. Like they're ahead of the game here. So anyways, phase 2 would be traditionally they should be able to move to phase 2 because they actually have a working implementation and they validated it now. Phase 2 would be a good place that they could if they held the vote. I would vote for them to advance. So. All right.
Great.
Standards. Okay. Anybody have questions on that? All right. Well, we're basically still hacking away.
Hopefully next week we can demo watermarking for real with WebGPU, or the week after. But
that sounds good to me.
A lot of hacking.
Let's do it. Oh, actually, Colin, let me show you a thing. I showed this last week. Did you see last week?
Your Protobuf stuff?
Yeah.
Yeah, I did. I'm still not quite there. But
Okay.
yeah. But
Okay.
you showed it to me 2 weeks ago that you got Protobufs working.
Well,
So I had to kind of take that and then use it and then stub out. It was change the nature of the problem. No, so right, this is the kind of the problem with Wasm, with WASI in general, is that as you expand out the use cases, there's always these C++ icebergs under the ocean, right?
that's a great
like
analogy.
OpenCV, right? Any sort of TensorFlow, Onyx runtime, protobufs, Boost, right? I'm not even, I mean, so many C++, major C++ projects that undergird everything, and people don't know they're using them because they're just writing Python or even Rust, OpenSSL, Ring, and you get into that stuff, and when you want that to work for a real code use case, all of a sudden you find out, oh no, the C++ is assuming protobufs, is assuming, I mean, it's definitely threads, right? That's like in everything. So that's where it gets really hard because you cannot, the Clang, right? The Clang, which supports WASI P2, right? Is just going to be like, nope, sorry, I'm out, right? And so then you have to kind of stub things out, and then you have to, you keep kind of going through the layers down. So yeah, I don't know. And Bailey did this great job on the protobufs with some WASI stubs, and then I pulled that in, and then I hit some like other stuff that.
Yeah, well, I started on like the as an outsider looking in, and I had some stubs that I got working like manually, like just recompiling over and over and over again until I beat them all away. Then I went through the abseil, which is like the more modern boost. So it's one of those giant icebergs that Protobuf depends on extremely heavily, and then added it there. But actually, this morning I just pushed up a better version of this now, where I got some feedback from the maintainer where if I do this, I get to get rid of a ton of different extra subs that I had in. So that was a good pro tip, and that cleaned it up quite a bit. So yeah, you still see the stuff about single threadedness, and you'll see me. I mean, it's not exactly true that WASI doesn't have mmap. We can virtualize it, but the performance is bad, and the whole point of this was to have performance. So I just was like, no, you don't want that.
Yeah.
So I made that decision for everybody.
And then and Protobus also has memory domains, which are similarly, where it's basically like I don't need virtual memory. That's too much overhead. Like I'll manage this piece of physical memory kind of stuff. And so like that's not going to work. So
Is that a C++ issue or product buffer? And sorry, I'm asking. It's just like,
There's
Yeah.
you know, I'm
many,
being
many such issues. But it's a C++ only because everything in the world, there's only a C++ implementation for this stuff. And everybody else just kind of
binding.
builds on top of it. Yeah.
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 Okay.
Yeah.
So that's why.
Also, do want to let y'all know there is a pure Rust Protobuf implementation in the works.
Yeah. So I
there's
was
one-
actually,
yeah.
that sounds fantastic. I was actually doing this all in C++ to make things easier for myself, unfortunately, which is a strange way to make things easier for yourself. But it was just because it was easier to go with Onyx Runtime in the C++ form rather than binding it through Rust. I mean, because you're going to be hit and clang either way. So, but yeah, but that would be great to have protos. I'm sure you will really benefit. wasmCloud will really benefit from a Rust native Protobuf implementation.
Yeah, I wonder how far away that is. I mean, it's just like everybody's has Proto C everywhere, you know? But yeah,
Oh,
I'm not surprised it's being
it's like-
consumed by Google.
Yeah, but like to be clear, this thing's existed and I like people use it. As far as I know, like there've been presentations on it and stuff like that. And Google announced that they were taking over the project. I
Yeah.
don't know. I want to say last year at a gRPC con. And so basically they've just been like working on it. And so they're gonna get this crate. They're gonna get this crate name. Like they're gonna get just the Protobuf crate, and then they'll be able to maintain it going forward.
Yeah, that'd be
Cool.
great. I mean, the Google is doing with Dawn, right? That's all C++.
Yeah, I have seen that Google's starting to embrace Rust more, which will be, I think, a great thing for the ecosystem as a whole. But I
Yeah.
think they have millions and millions of lines of C++ and lead a lot of even the C++ standards. So I expect these other ones are going to continue and people are going to need this no matter what anyways. One thing that I did show last week, the way that I've been testing all this stuff out, I pushed up, if you go to GitHub, Ricochet, WASI Protobuf, you can grab that and you can just make that work off the shelf. And that just includes the like stubs that I sent you, Colin.
Yeah.
The only trick here though is that basically I'm building abseil and Protobuf from source. And this is how I was testing out my change, basically, was rebuilding locally against abseil and then telling Protobuf to rebuild from source. And Protobuf has a CMake flag that says, oh, you've got abseil that you're building from source. I won't bundle mine in. So basically,
Maybe I need to, yeah, I'll probably need to talk to you more. I just wanted to see how far I could get. And I'm trying to get ready for everything done that isn't WebAssembly for this week. Well, it actually is WebAssembly, but whatever, Adobe WebAssembly. But so we'll have the decks cleared for next week.
yeah, I mean, just the long story short there is that I actually have a Protobuf that's building from source that has 0 changes because of that abseil change. So you won't.
Oh, okay, great.
I'd originally gotten you guys working by pinning it to an older version of Protobuf before they depended on a version of abseil that had all of these additional atomics that then we had to stub out because abseil actually had WASI support for many years. It's just once they added the atomics, they didn't flag WASI out of it. So it was just needing an update.
And are you doing P1 and then using an adapter, or are you just going right to P2?
Right to P2.
Okay.
Yeah.
All right. Yeah. As soon as I can, I will give it another shot.
Cool. Yeah. Well, I guess you can if you go to my repo, I'm not going to push out my local source building stuff because I don't think anybody, unless they love CMake, could get that working locally just by themselves without following a README like put a file here and all this kind of stuff. So I'm going to keep my stub and like the thing that works. But if you want tips, I'm happy to give them. But what's in the repo actually shows how to build for P1 and P2. And you can compare both of them side by side.
Yeah. I mean, the most frustrating, this isn't a frustration with you, obviously, but the most frustrating thing just was that I had P1 actually using WebGPU on Monday, and I could not get P2 working. My own fault, of course. It's not like I know what I'm doing. but so close. So we'll
Yeah.
get it next week.
I mean, you basically have to grow an entire gray beard to be able to do a lot of these
I'm
C++
working on it. I stopped
things.
shaving. It drove me insane.
Yeah. Anyways, I think we'll have a lot of the story landed. And then with bindgen released the C++ bindgen changes, so that's feature complete for WASI
Haley
P3
did
now.
that as well. Yeah, that was all. That might have been when I lost my mind a little bit. I
Yeah,
was like,
well,
I
it
can't
just
even
didn't.
with bindgen. Come on. But yeah,
Yeah.
no, with bindgen for C++ is working again. I think it was it the C# changes or something? Somebody, it's like a Microsoft thing.
Well,
What
what
broke
I
it?
found, no, actually,
Oh,
what I
okay.
found is that it just like had very much been in a POC state, and didn't implement most things. And so then I made sure that it went and implemented all the things, and now all the spec tests, except for the latest WASI P3 async stuff, now all pass. So,
Oh wait,
um,
the P3 async stuff now works too with bindgen?
no,
Oh, okay.
we
The
can
opposite
talk
of
about
what you
that
said.
if you'd like, but
No, I
I
didn't
put
know
it.
what you said at the end. I thought, okay,
Sorry,
so it
yeah,
doesn't
no,
work. Oh, got it.
P2, just P2.
P2
P3
works.
stuff is what I was like, all right, P3 is a separate thing. We'll do that later. Once I have cooperative threads, it'll be so much easier. And I put in a ton of thought into what the P3 one would look like. So if you're into that, let me drop that link. And I got feedback on it from Sai. It's just the classic. It's a classic problem in C++ specifically on what version of C++ can you depend on. Um, and there's a thing that I really want to depend on, which aligns perfectly with cooperative threads, which is the direction that basically all modern languages have moved to, which is something like a green threading model
Yeah.
or a coroutine. And I don't want a whole thread for the interop between components or between the component and the host. I want a coroutine there. So that's the rough sketch for that. But as Christoph, who wrote the original C++ bindgen, he called out, was like, hey, my thing is, tied to C++ 17 and the world is still stuck on 14. So we got to make a call there on
Yeah,
timing
that's
on that.
tricky. C++, you're inheriting all the problems. So what's going on with wasi-tls? Idea.
Yeah. Aditi, do you want to talk? You've got a comment here. I could read it out loud, or you could if you wanted.
Oh, okay. So,
Okay.
so wasi-tls, is that trying to do like all of Rust crypto, basically? Or is it trying to just do over the wire, like
It's definitely
TL?
separate from crypto. It's very much
Okay.
about implementing the pieces of TLS that you need for a socket.
Okay.
And it is used in a lot of different places. Well, Aditi, I can ask you this offline, but I'm curious if you talked to James or if you talked to Joel. And I'm interested in what he's into there. But yeah, crypto stuff is super challenging. You're not the only person that's actually asking a lot of these questions right now. We had a pretty long cryptography thread going on in the Bytecode Alliance Zulip recently too, on some of the crypto libraries from Frank Dennis that he got compiling to WebAssembly. But I think my stance is, yeah, I want to get this wasi-tls proposal advanced as quickly as possible and potentially as part of Preview 3, basically.
Yeah.
Because a lot of people need this.
Well, I mean, Rust crypto has come a really, really long way. And I've been able to migrate a lot of the stuff. We've been able to migrate a lot of the stuff from OpenSSL into it. And it's a lot easier to work with if we're already doing stuff in Rust. I mean, I think where it's going to be a challenge is the auditing for FIPS when people want to do that. Somebody's going to need to have some pretty deep pockets. But the yeah, I mean, you can do all that stuff in Rust crypto these days. I just recently RFC 3161 stuff was added, and I'll hopefully pick that up in my stuff. So yeah, I'm pretty upbeat that wasi-tls is much more possible than when I started asking about it, 4 or 5 years ago. So
Wait, when you say the wasi-tls is the one who's under the WebAssembly, so that's like for the socket itself, not so much for the cryptography happening behind?
Ugh, it's it's a lot there to unpack. Kind of yeah, Aditya, that makes sense for your comment there, is that we hadn't revved wasi-tls to think of P3 in mind, basically, is one of the things that needs to get done. Let me link you the proposal. Dave Barker, Baker, something like that. He is the champion for WASI sockets and has also contributed a ton to wasi-tls, unsurprisingly. And he has this table that I want to drop in here for everybody, but I can't remember exactly where it is. But essentially, he shows like all the different things that he's evaluated and the compatibility and how it works across like all of these different language ecosystems. He did like this giant matrix for everybody as part of the WebAssembly WASI CG SG call. I'm just trying to find.
I remember
Well,
all this.
yeah, it was an awesome talk.
Yeah.
And I know
But
he pulled it up in a GitHub issue, but I'm just blanking on where it is.
I
I
mean,
think it's actually over on the socket side.
I think the only thing, it might make sense now for this to be separate from sockets because sockets is much farther along, but eventually it should probably just be. It seems it's really just written for sockets, right? I don't
Yeah.
know. For what that's worth.
Yeah, we wanted to push it forward more for that because that's the key use case. But and you can see the evaluations between using WASI crypto or like just compiling things in like Rust crypto. What are the options? So anyways, that would be better than me fumbling through my memories to give you the details. Go read Dave's writing there. He did a great job. And maybe
Yeah, not using yeah, don't use compiled libraries and don't use WASI crypto. Yeah. Both I agree with. I don't know. This made sense at the time, I'm sure. I mean, it still makes sense. I'm just saying at the time I heard it, it all made sense. So I think it still does.
here.
All right.
Here's the presentation. All right.
Bailey, I have a question for you.
Yeah.
When I create open pull requests, should I be the one who ping people until they react to me, or should I just ping once and sit and wait? I don't know how people prefer to work, and I don't want to come across pedantic or whatever.
Yeah, well, I mean, it depends on the person. In the wasmCloud space, you can just ping us directly. We're happy to get DMs. Definitely me, where rest in peace my inbox after I spammed the entire world in WebAssembly. That's been a problem. Now, I think if you're talking about in general in open source, you shouldn't ping anybody unless your pull request has green CI. You know, like people generally won't even look at it, right, until it's green and passing. And if it is, and you've addressed all the feedback, and it's been a couple days, totally cool. My first approach is I just ping, you know, in the PR, like, hey, I think this is ready now. I think it's usually the de facto like soft, gentle push. I start there usually before I go to DMs.
Sounds good.
Are you talking about map? The map that you made?
Yeah, and I just realized. Fuck yeah, yeah, and I just realized that my CI was passing. I swear God, it was locally passing. So, whoops.
Well, I know what that was. I looked at it when I was making my C++ changes. So Yortis, what bit you is the async stuff. So we had async PRs failing at the time that you had created that PR because we were making this big change.
Okay, well,
And
I'm glad to hear that because I'm the type of person who definitely would not like to bother people if my CI is not green.
Yeah.
Now looking at it, it's like, wait, this was green.
Well, I mentioned it because I saw that it wasn't green a couple days ago. Anyways, a week ago, I merged Alex's change that got the async back to passing. So I think if you rebase on main, it should just get to green.
Okay. Oof. All right. Good to. I didn't even realize that was not passing. By the way, that's I'm like, wait, what happened here? Okay, thank you so much. But yeah, it's related to that. I just want to figure out what I should be doing.
Yeah, cool. Well, seems like you're doing all the right things. It's a little weird having CI on main failing, but that was a valid state. And like we were basically saying we cannot release until we fix this.
Yeah. Okay, good. All right, revising it right now. Thank you. Sorry,
Thank you.
I'm abusing you over here. But this
No, it's
stuff.
all good. It's good. It's good to see you, Yordis.
Yeah.
All right. I'll see everybody next week. Colin, maybe sooner. We'll see. All right.
Yeah, hopefully not too much because it's just gonna work.